Hello, my name is Shannon and today I'll be presenting my presentation on the human digestive system and nutrition. I'll be discussing the structure and function of the human digestive system while discussing the dietary requirements for good human nutrition. We will start by looking at the main roles the requirements of a balanced diet play, the structure and the function of each organ in the digestive system, and showing my research on what is fact and what is fiction when it comes to nutrition. The agenda is we'll look at the 7 requirements for a balanced diet in humans and their main roles, the effects of dietary imbalance and the symptoms of nutrient deficiency, the dietary recommendations that are currently believed to contribute to the prevention of disease, the anatomical structure of the human alimentary canal, the functions of each part of the human alimentary canal, including mechanical and chemical and absorption, the histology of the alimentary canal, identifying the stomach, duodenum and ileum, the main functions of the liver in relation to digestive. So the 7 requirements of a balanced diet in humans and their main roles are carbohydrates first. The body uses carbohydrates, the primary source of energy for movement and functioning. As our bodies are constantly functioning through the day, a large supply of energy is required. Carbohydrates are one of the 3 macronutrients that our bodies require. Second is protein. Because of their many variants of uses, proteins are considered the building blocks of the body and are essential to the body as protein mends the tissue, gains lean muscle, as well as aiding in the body's healing process. Next is fats. Fats help give your body energy, they protect your organs, support cell growth, keep cholesterol and blood pressure under control, and help your body absorb vital nutrients like vitamin A, vitamin D, and vitamin E. Next we have fibre. Dietary fibre is found in the outer walls of fruits and vegetables and seeds. It has no calories but increases the bulk of food and helps with healthy digestion. Fibre helps assist with regulating stool function. Vitamins. Vitamins are organic compounds which produce various reactions to the body. They are separated into 2 groups: fat soluble, which can only be used as the presence of fat and tend to stay longer within the body; water soluble, which are only used in the presence of water. These are typically expelled from the body faster and stored in smaller quantities. We then have minerals. Minerals are inorganic compounds that are found in nature. They are required to maintain levels of fluid and within the outside cells in the body. They convert food into usable substances and support bone growth. Next we have water. Water is a necessary requirement for the body to function. Unlike carbohydrates, fat and some vitamins, the body cannot store, thus it cannot be implemented as part of an everyday diet. Water is comprised of H2O and supports almost all functions of the body. Next we have the effects of a dietary imbalance. So first we have malnutrition, which, as it says, affects 1 in 3 people all over the world. This occurs when a person is not consuming the correct amount of nutrients required for their body to function. Acute malnutrition is when a person is immediately at risk of complications, illness, or even death through malnutrition, and chronic malnutrition is when a person is not fully developed due to the malnutrition. Next we have starvation. Starvation is caused through not consuming enough calories, and the damages of this are severe. Symptoms of starvation include anemia, dizziness, tiredness, a bloated stomach, severe weakness, and in severe cases it also causes death. Obesity we have in figure 3. Obesity is when a person has a high excess of body fat, which can be checked through calculating your BMI from your weight and height of an individual to determine if they're a healthy weight. Then last we have cholesterol. There are multiple forms of food there are multiple forms of fats that are found in our food. It is important not to consume more healthy fats and not to consume more health fats and not too much low density. When a person contains too much low density fats, it increases the risk of heart disease. The symptoms of nutrient deficiency are decreased structure, fragile skin, metabolic disturbances, persistent illnesses, poor appetite, poor wound healing, and they're more prone to illnesses. The most common nutrient deficiencies there are iron, which iron is an essential for making red blood cells, which carry oxygen throughout the body. A deficiency in iron can lead to anemia. We can up our iron intake through food like liver, red meat, beans, nuts and dried food. Most people are able to get enough iron for a balanced diet, but sometimes you may need supplements, and then your GP can also give that to you. Calcium is something else that we can be deficient in. It's important that we get enough calcium in our diets, as deficiency can result in weakened fragile bones. We're able to get calcium into our diets through dairy products, leafy greens and legumes. Nutrient shortages and an unbalanced diet have a negative impact on the body that can result in long-term chronic symptoms and even death in some cases. Therefore, it's critical to recognise the symptoms of an imbalance and malnourishment, as well as the requirement for a healthy, balanced diet. Next, we have diet recommendations that are currently believed to contribute to the prevention of disease. A person's environment, medical history and unique circumstances can all influence their eating habits. The NHS put together an Eat Well guide which promotes a healthy, balanced diet. A balanced diet contains the 5 food groups. You've got your fruit and vegetables, your proteins, your grains and dairy, and at least half an individual's daily intake should come from carbohydrates. That's what we have here with the bread and things. At least 400 grams of fruit and vegetables can be consumed according to the World Health Organization. In addition, a person's daily intake of salt should not exceed 5 grams and their total fat intake should not exceed 30 grams of their total energy intake. It was documented for NHS that following a balanced diet and lifestyle with physical activity reduced a person's risk of experiencing chronic diseases and health complications such as diabetes, osteoporosis and heart disease. Water is also an essential part of a health diet and must be consumed daily. Adults should aim for between 2 to 3 litres of water a day. High-fat foods like cake, butter, chocolate, there is a space for them, are not a requirement for a healthy diet, and these foods should be limited. But that's why they're on it, so they should be limited, but obviously people are still going to have these foods in their diet. Next we have the structure of the human alimentary canal. So the digestive tract is another name for the alimentary canal. Food travels through the body via the lengthy tube of organs. It includes the stomach, intestines, the esophagus, and extends from the mouth to the anus. This is the place where the waste will exit. The digestive tract of an adult is roughly 30 feet long. Organs used within the digestive system fall into 2 categories. The alimentary canal organs. These are the organs with the primary function of intaking food for digestive purposes, and accessory organs. These organs secrete substances which are used within the digestive process, but we do not have food pass through the organ itself for digestion. The key areas of the digestive system include the mouth. The mouth is used for the process of chewing food and breaking it down into smaller pieces. The sphinx, as the muscular wall of the pharynx contracts, the process of swallowing food becomes involuntary and it's pushed further into the esophagus. The esophagus pushes solids down the process of the peristalsis. Liquids and solids transfer down with the support of gravity. The liver is an accessory organ that produces bile. Bile contains water, salt and pigment, bilirubin and cholesterol. The gallbladder stores bile to support the fat digestion. The stomach is up here. The stomach is an organ with an acidic liquid that coats food as it's digested. As the bolus mixes with the gastric juices it produces by the stomach, it becomes a substance called chyme. The pancreas aims to regulate sugar within the body and assists in digestion. It produces enzymes which break down food molecules into proteins, sugar, starches and fats. The small intestine is approximately 6 to 7 millimeters in length. Its primary role is digestion, absorption and nutrients in the body. The large intestine is roughly 1.5 meters in length and is much thicker than the small intestine. It absorbs vitamins into the body and prepares leftover food particles into feces to remove them from the body. Then we have the rectum. The rectum is temporary storage to store waste product in the body. And then the anal cavity. This is the end of the digestive system. feces is evacuated as waste product from the body. Then next we have the functions of each part of the human alimentary canal, including mechanical and chemical absorption. There's two key methods of digestion which take place within the body. Mechanical digestion involves physically breaking down food substances into smaller particles to more effectively undergo chemical digestion. The role of chemical digestion is to further degrade the molecular structure of the ingested compounds by digestive enzymes into a form that is absorbable into the bloodstream. The physical breakdown of food during mechanical digestion makes it easier for the intestines to absorb nutrients. The mouth is used to chew food, the larynx and esophagus are used to swallow it, and the stomach is used to churn it into gastric acid during the mechanical digestion process. Then we've got the enzymes for chemical digestion. Proteins come together to form enzymes which quicken bodily reactions. Because they guarantee that food is broken down into smaller molecules, smaller molecules and ready for the body to absorb, enzymes play a critical role in the digestive process. The rate at which food is broken down chemically would not be fast enough without enzymes. The key types of enzymes include carbohydrate, breaks down carbohydrase, which breaks down the carbohydrates and is located in areas like the mouth, pancreas and small intestine. The protease, which breaks down protein, located in areas such as the stomach, pancreas and small intestine. The lipase, which breaks down lipids, located in areas such as the pancreas and small intestines. Enzymes are moulded to the shape of the molecules they interact with during a reaction. The substrate is the region where a molecule and an enzyme interact. The enzyme starts to disable a molecule into its constituent base products as soon as it binds to it. After finishing, the products and enzymes separate, allowing the enzyme to start the process all over. Then we have the histology of the alimentary canal. The study of biological tissue's microscope structure is called histology, or microscopic anatomy. Biological material is examined histolically by slicing a small portion of the organism and looking at the slide under a microscope. To help identify various biological structures within the body, different coloured stains and dyes are applied to slides. Food that enters the body is broken down by stomach using gastric acid. To stop harmful organisms from proliferating inside the body, the solution uses a combination of hyaluronic acid. Additionally, the stomach secretes enzymes to break down proteins and fat. The stomach's histology consists of 4 layers, which can be abbreviated as MS. They have mucosa, which is the core area that comprises this inner lining of the stomach. When the mucosa contracts, the gastric glands within secrete the gastric fluid used to digest food within the stomach. Submucosa. This is a thick, durable connective tissue which is used to join the mucosa to the muscle underneath. Muscularis externa. These are 3 layers of muscularis externa which form in different directions from one another. These layers contract to assist with the process of churning used to digest food in the stomach. Serosa lines the outside of the stomach. It is used to reduce friction and protect the stomach as it moves within the body. Food molecules enter the bloodstream from the small intestine after digestion. The first and shortest section of the small intestine is duodenum's lining. It is 25 centimetres long and after the stomach aids the first absorption of partially digested food. The plicae circles or circular folds that encircle the duodenum and enchant its surface area for absorption are a distinctive characteristic of the small intestine. The duodenum is comprised of 3 layers. Then we have the liver. So the liver is a brown cone-shaped organ that sits above the right kidney, intestines and the stomach on the right side of the abdominal cavity. Under the 5 bottom ribs, it is the body's second largest organ. The liver performs a variety of tasks for the body, such as purifying blood by eliminating impurities, generating glucose via the process of gluconeogenesis and aiding in digestion. Furthermore, the liver helps store the simple sugars, in this case glucose, so that they can be used later to create new carbohydrates. Lipids or fats and oils are broken down by a process called bile, which is produced by the liver. It travels through the body's bile duct and it's kept in the gallbladder. Bile aids in fat emulsification and acid neutralization. Food molecules are acidic when they travel through the stomach and past the liver. In order to neutralize the product before it enters the small intestine, bile helps to provide an alkaline base. Bile breaks down fat as it passes through the liver into smaller pieces, improving the absorption of lipase enzymes. And that is us at the end. So thank you for listening, and does anyone have any questions? Thank you.